Hey there, folks. So today we're going to look at factoring polynomials, and we're going to specifically look at the sum or difference of two cubes pattern of factoring. So we're going to start with the difference of two cubes. We have a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. This is really similar to the difference of two squares pattern. It's the same kind of logic that if we just distribute this, if we just distribute this out, if we were to just distribute this out, we would always end up with a cubed minus b cubed. One thing to help you remember this is I always think of it as SOAP. All right, because you'll notice that we're also going to do a sum of cubes. That's the next section, and it's the exact same pattern. The signs are just different, and the SOAP here, you don't forget to use your SOAP, is just a way for us to remember the signs that we have going on here. So the first sign is always the same. So if you're doing a difference, it's a minus sign. If you're doing a sum, it's a addition sign. So here, like, it's a cubed minus b cubed. So the first sign is a minus b because it's the same sign. Then the next sign is opposite. So we have a minus b, so the second sign is plus. And then the last sign is always positive. This last sign is always positive. So if I'm going to do this pattern, I have a cubed minus b cubed. So I kind of need to figure out what a and b are based on a cubed and b cubed. So if I see a cubic binomial like this, x cubed minus 27, well, I have x, and the cube root of 27 is 3. So this factors by following the pattern to x minus 3 times x squared plus 3x plus 9. And I factored it. You'll notice that this last one is unfactorable. Nothing multiplies to 9 and adds to 3. We can do the same thing with, like, x squared. We can do the same thing with x to the 6th here. Because x to the 6th is x squared cubed, and this is 2 cubed. 8 is 2 cubed. So therefore I'll have x squared minus 2 times x to the 4th plus 2x plus 4. Just using my formula. This next one is a little bit more complicated. X to the 3y cubed minus 64. Well, 64 is 4 cubed. So now we need to figure out what would be in here. So it would be x to the y cubed. Remember, when we have an exponent to an exponent, we multiply those two exponents. So we multiply y cubed and 3 to get 3y cubed. So therefore, this would be x to the y cubed minus 4 times x to the 2y cubed plus 4x to the y cubed plus 16. Lastly here, we should always check for a GCF. Here we have 3x to the 4th minus 24. Both of these have a factor of 3x, so we should start with that, and that'll give me x cubed minus 8. X cubed, so that's just x cubed, and then minus 2 cubed, right? So now I'll have 3x, because that's the GCF I took out, and then I'll have x minus 2 times, which we've already kind of done this problem, right? It'll be x squared plus 2x plus 4. Squaring that too. All right, that's difference. Sum is very similar. And again, we want to use our SOAP, which is same sign, opposite sign, and then it's always positive. So if I have x cubed plus 27, that would be x cubed plus 3 cubed. Well, that would mean that I have x plus 3, same sign, times x squared, opposite sign, minus 3x, AB, plus 9, always positive. We can even have coefficients in front of the cubic term. So here, this would be 2y all cubed plus 1 cubed. Therefore, this factors to 2y, same sign, plus 1 times 4y squared plus 4y plus 1. I do have to say, I said plus when I meant minus. It's an opposite sign in my SOAP. Lastly, 125x cubed plus 27. 125x cubed would be 5x quantity cubed plus 3 cubed. Therefore, if I have that in like A and B, right, that would be 5x plus 3, same sign, 25x squared, a squared, minus opposite sign. Then it would be 15x plus, always positive, b cubed, which is 9. B squared, excuse me, which is 9. Thanks, guys. Have a good day.